Okay, so in this video I'd like to work through three practice problems, and these all come from homework number 3, homework number 3 on MathXL. So on the MathXL page it looks something like this, homework number 3. And now this happens to be the first question out of 10 for this homework assignment, and I've labeled it as 4.1.9 because that's the labeling convention from the homework assignment. If I called it number 1, then some of you may have seen a slightly different identifier here. But if you're looking at that identifying value, then this is the style of question that you're going to see. So in the Khan Academy pages, we don't talk a whole lot about solving systems of equations by graphing, so I'm relying on you to practice with MathXL to review this concept. And this set of instructions tells us to solve the system by graphing. Now my recommendation is to solve the system by first rewriting these functions. So in the first one I have x plus y equals 4. So I'm going to come back to my notebook paper. I'm going to record x plus y equals 4. And then my second equation was x minus 3y equals 12. And that's our system of equations. There's only one coordinate, or there should only be one coordinate that satisfies both equations, and we'll see that by graphing an intersection of two lines. If the two lines don't intersect, or if they are lying on top of one another, then that's going to imply different types of solutions. Well, the first thing we have to do is rewrite each function, and we do that by getting y by itself. So if I jump off to the side here, I might say that x plus y is equal to 4, but if I subtract x from both sides of the equation, then I'll be left with y by itself is equal to negative x plus 4. And I'm writing that result this way instead of 4 minus x, so that the graph looks more like our slope-intercept form of y equals mx plus b. Our slope-intercept form of an equation looks like this, with y equals a number times x plus b. So the slope of our line is negative 1, and the y-intercept of this line is positive 4. If I were to do the same with the second equation, it might look like this. I'll start with x minus 3y equals 12. And again, I can subtract x from both sides. I'm left with negative 3y equals negative 1x plus 12. Now I'll divide both sides by negative 3, and that's going to give me this y value by itself. And I have to keep in mind that when I divide this entire side of the equation, I'm actually dividing both components of this side of the equation by negative 3. So it might be helpful to write it this way to keep yourself organized. Well, I have a negative 1 divided by negative 3, and that's going to result in the fraction 1/3. And the x it can be written by itself. 12 divided by negative 3 leaves me with negative 4. And now I have a second equation that can be graphed. So we can try to sketch a graph by hand, but part of the MathXL question actually asks you to graph the points over here. And so to graph the, I shouldn't say points, but the lines, what we'll do, I think, is choose this graphing tool here. This is going to allow us to graph a point by plotting, or I'm sorry, graph a line by plotting 2 points. As with most linear equations, I think it's a good idea to plot our y-intercept. And so our y-intercept in this example here is 4. And then from that intercept, y-intercept, we'll plot our slope, our next point following our slope, which is negative 1, or when written as a fraction, negative 1/1. So let's see what happens. Here we have our point, our line creation tool based on 2 points. So I'm going to place a dot right here at 4, and then I'm going to move my cursor down 1 and over 1 to the right to place another dot. So again, by plotting our y-intercept first, and then following our slope of negative 1/1, we've now graphed that first line. With our second line, we have to plot the y-intercept of -4. This time it's a -4 below the x-axis. And our slope, which is 1/3, rise 1, run 3. So we'll again choose our line graphing tool. We'll start with a coordinate right here at -4. And from that coordinate, we will rise 1, run 3, and we would plot another point. Those 2 points have created a line. And now we can identify our solution. The solution to the system of equation is represented by the coordinate where these 2 points intersect. And so that looks to me like an x value of 6 and a y value of -2. So on paper, I would say that the solution is the coordinate 6, -2. So let's see how we would enter that into MathXL. Well, I had the recording tool paused because I was looking for a text box to type in this solution. The solution exists at an x value of 6 with a y value of -2, but there was no spot for me to enter that. What I ended up doing was, with the graph complete, I just clicked check answer, and this was the solution that this particular question was asking for. So that's kind of interesting to me, but that's exactly what MathXL was looking for, so we'll go with it. And aha, here's the part that I was looking for. The second component of the question then says for us to decide if there's one solution, if there is a set of solutions, or if there is no solution. Well, as I said, there is one solution, and our instructions does say to simplify our answer. If we come across any fractions, that should be simplified. And we should also type our answer in an ordered pair. So you can use the built-in tools on the MathXL page to produce a pair of, an ordered pair, a coordinate that you can type the result into, or you can simply use your keyboard and type the results as well. So on my keyboard, I'm going to go ahead and write 6, and I'll jump over a space, -2. See here, I might have to delete that empty space. There we go. So 6, -2, that looks pretty good to me. So when we check our answers, we get credit for that as well. The next problem appears to be a system by graphing equation as well, so you can use the same technique as before. I would like to jump ahead to 4.1.15. In this example, we must use the substitution method to solve a system of equations. Now I know the substitution method would be a good choice to use here because one of our equations has a variable all by itself. Whenever you see a y equals something or x equals something, if there's ever a letter that's all by itself, that's a good indication that we're going to use the substitution method. And the reason for that is because in both of these equations, y means the same thing. So in row 1 and in row 2, y means the same thing. And so if y up here means the same thing as y down here, and down here we're told that y is equal to 3x, then it stands to reason that I can take this 3x and I can put it in place of this y. I'm going to change that y to the combination 3x. And by doing so, I'm going to end up with this expression, x plus 3x, and that expression is equal to the numeric value 12, just as row 1 was before. Well, this is helpful because if x plus 3x is equal to 12, then when I combine these two like terms, I see that 4x is equal to 12. And now I can divide both sides by 4. And I find that x by itself, because this will cancel, x by itself is equal to the value 3. And here again, the value of x in the numerator and the not numerator, but in the first equation, and the value of x in the second equation are the same thing. So if I now know that x is actually equal to the number 3, then I can use that calculated result to find out what y is. And we can use either equation, but I kind of like this second one myself. If I know that y is equal to 3x, and I'm also told that that x, is equal to the number 3, then y would be equal to the number 3 times 3, and therefore y is equal to 9. Now that we know that x is 3 and y is 9, we can actually put together our final answer in coordinate form as the ordered pair 3, 9. Now, if you had solved these in a different order and found your y value first and then your x value, please keep in mind that in all ordered pairs, the order matters. X must be labeled first, the value for x must be labeled first, and the value for y must be labeled second. So let's see if we can enter this as a solution into MathXL. So since there was a solution, I'm going to go ahead and choose A, and I'm going to indicate that the solution is the ordered pair. And here I'm just going to type all of the pieces. We've got, 3, 9, close the parentheses. Again, the blue text here is telling us to type an ordered pair, so it's important that we include those parentheses, otherwise you won't receive credit for your work. I'm pretty confident in my solution, so I'll check my answer, and it looks like we did okay. For the last question in this video, I would like to jump ahead to 4.1.23 and illustrate the elimination process. So in 4.1.23, we see a system that looks something like this. And with the elimination method, the goal here is to combine row 1 with row 2 with the hopes of one of the variables dropping away when we combine them. And when we combine these, I often get rid of this brace that's over here on the left-hand side, and I just imagine what would happen if I add the two rows together, or sometimes subtract the two rows together. Now, if I add these together, you'll see that this negative x plus x is going to turn to a 0, and effectively those terms would be eliminated. If I were to subtract them, then in the middle here, 2y take away 2y. Now again, take 2y take away another positive 2y. 2y minus 2y is 0, and that would effectively eliminate the y values. Now either technique is appropriate and acceptable, but whenever possible I tend to add my values together. I make fewer mistakes this way. So if I take column by column and add these two rows together, negative x plus 1x is 0x. That term has essentially been eliminated. 2y plus 2y is now 4y, and 0 plus 1 is equal to 1. Again, because of the elimination, 0x, that has been eliminated. 0 times x is nothing. So we're now left with the equation 4y equals 1. When we divide both sides by 4, we're left with a value y equals 1/4. Now that's not our complete solution. We've got to be careful here. That's only part of our solution. But here again, much like the substitution process, if I take this 1/4 and substitute it back into y, either in the first equation or the second equation, we should have enough information to isolate x. I think I'm going to use this second equation personally because, well, this x value is a positive x value, and I kind of like working with positive numbers instead of negative numbers. So I have x plus 2y equals 1. I also know that y is equal to 1/4, so I'll make that substitution. And 2 times a fourth is equal to 1/2. And if I know that x plus a half is equal to 1, then by subtracting 1/2 from both sides of the equation, we'll cancel these here, and I'm left with x being equal to 1/2. So our solution of y being 1/4 and x being 1/2 written together as an ordered pair, keeping in mind that the x value should be written first, then our solution should look like this: 1/2, comma, 1/4. Now if we jump out to MathXL, it looks like a solution has been identified. This time the instructions say to simplify the answer and type an ordered pair like we've seen before. And the blue notes also go on to say to use integers or fractions for any numbers in the expression. So integers meaning numbers without decimals, or fractions to report our final answer. So let's see if we can get this entered in here. Now on the keyboard I'll type 1 slash. Now I don't want to use this backward slash, I'm going to use this forward slash. By pressing the forward slash on your keyboard, that's automatically going to create a fraction. So 1/2 for our x value. And I'll press the right arrow to get out of that fraction. And we'll separate these two with a comma. And in the second coordinate, I want 1/4 to create 1/4. And I created the fraction bar again with that slash. So I'll use my arrow keys now to jump out of that fraction. You can see my cursor is active on the outside. I must close the ordered pair with another set of parentheses. And now we've got a solution that I think would work just fine. X value of 1/2, y value of 1/4. We did use fractions to represent our numbers. And now when we check our work, it looks like we've got credit. So hopefully this video helps you with these types of questions. Of course, you always do have access to the question help options for these problems. Please make use of them as you encounter trouble on these questions. Email me at any time and I'll try to respond as quickly as I can with a recorded video like this, or perhaps set up a Zoom call if it would help in the process. Thanks for watching.